Okay, welcome everybody. I wanted to welcome our three speakers today. By way of introduction, my name is Joe Hankey. I'm a program specialist with Alberta Eco Trust with the ENBIX initiative. And today we're presenting the first in our residential technology series. And we're going to be focusing on air source heat pumps and HVAC considerations. We have three excellent speakers with us today who can present on their experience over time. I just wanted to note this event is hosted by ENBIX as well as SSRIA. So we're going to introduce a little bit about ENBIX and SSRIA to start. Over the next few months, we'll be hosting more of these learning sessions to explore conventional and innovative residential building solutions that are used in Alberta. And these contribute to airtight, low carbon, and high performance buildings. So some of the topics we've got coming up are going to include air barriers, insulation, fenestration, and windows. Today, we're going to focus on heat pumps and HVAC. So I know people are always really excited about these topics. I want to take a minute just to acknowledge that Alberta Eco Trust Foundation operates across all of Alberta. So we are proud to recognize the traditional territories of many diverse Indigenous peoples. This includes both Treaty 6, 7, and Treaty 8 nations, such as the Blackfoot Confederacy, comprising of the Siksika, Kainai, Piikani First Nations, as well as the Cree, Dene, Nakota Sioux, Saulteaux, and the Métis Nation of Alberta. I always feel that this is such a good opportunity when we're talking about sustainability that we take the time to make a land acknowledgement and acknowledge that we're trying to continue the work of traditional land keepers by maintaining and preserving our resources and our environment. Just to speak a little bit about Alberta Eco Trust for people who may not know, we are a charitable foundation that was founded in order to support environmental initiatives throughout Alberta. We have over 30 years in operation and we work through many different avenues, including working with grants, impact investments, partnerships, and then our direct programming and initiatives, which includes our buildings initiatives. We have two buildings initiatives. We have the ENBIX as well as the Retrofit Accelerator. Today, ENBIX is where the Emissions Neutral Building Information Exchange. We try and bring together industry with an emphasis on the construction, renovation, and development industries with a focus on reducing emissions from the built environment. We want to build capacity, share knowledge, as well as build partnerships that lead to an emissions neutral future in Alberta. Our Retrofit Accelerator program works with building owners and operators in order to demystify and provide guidance on deep retrofits in order to make step change in the operational energy usage in buildings as they age. Now I'll hand it over to Pam to give a couple of introductions about SSRIA.
Fantastic. Thanks, Joe. You can actually head to the next slide. So SSRIA stands for the Smart, Sustainable, Resilient Infrastructure Association. We are a not-for-profit industry association that fosters collaboration to accelerate the adoption of innovative solutions in the built environment, specifically that reduce greenhouse gas emissions, which is why we're so closely aligned with the work that Alberta Eco Trust and ENBIX is doing. We are working towards our mission through a number of different channels, and you can actually head to the next slide, Joe. One of those being that since 2020, we've actually supported through funding the demonstration of 20 projects that support the demonstration and validation of technologies that can reduce greenhouse gas emissions in the built environment, with a big goal that came out of that was to be able to share that information with all of you and with industry very widely. Many of those projects actually do have an air source heat pump component, and so lots of great opportunities to learn about how air source heat pumps are working in a variety of different buildings. When we kind of move on from this, I can put a link in the chat to our resource library, which can actually be searched by HVAC systems so that you can kind of dig into what those specific projects are. Some other areas that we work in, as I mentioned, looking to facilitate collaboration through the building of a network. We also support innovative businesses with their strategic growth through a number of different programs. And as I just mentioned, kind of collecting a lot of this knowledge and expertise, particularly from these projects, and putting it in that resource library. I think that's all I'll share for now. But yeah, happy to answer any questions. If you want to reach out to me, I can share my my info in the chat as well.
Awesome. Thanks, Pam. So we're really excited today. We've got three excellent speakers with us today who bring a wealth of experience in the HVAC as well as specifically with regards to heat pumps to us. Combined, they have over 60 years of experience and across a wide variety of projects, particularly around our conversation around heat pumps and some of the novel systems for HVAC. Our first speaker today is going to be Don Curry. Don is an estimator and installer with Weiss-Johnson. He has specialized in alternative HVAC systems, including cold climate heat pumps for over 15 years. Our second speaker today is going to be Jordan Hilton. Jordan is the owner and lead residential HVAC technician for AirTech. He started his career in HVAC over 20 years ago, and after many years working with a variety of clients in both residential and commercial spaces, he started his own company, AirTech, in 2022, which is focused on innovation and applications of cold climate heat pumps. And then lastly, we have Darrell Durrand. So Darrell is the market development representative of Energy Saving Products Ltd, and ESP, also well known for its high velocity product line. So Darrell brings in the manufacturer experience to this conversation. And he's been working in the industry for over 25 years, providing both training to contractors as well as customer support and new market leads for high velocity. So really excited. We've got a good diverse set of experiences. So with that, I'm going to actually hand it over to Don to start his presentation.
Okay, great. Thank you for the introduction. I'm just going to go back to my screen here. Okay, great. Well, thank you for giving me the opportunity to get on here and give a little bit of, I guess, insight into kind of what we've been up against as a contractor from a contractor's perspective. So, you know, I'm here representing, obviously, Weiss-Johnson. A little background, I won't get too heavy into the background on all the offerings as they do quite a bit. But, you know, we've been around since about 1977, one of the oldest companies here in Edmonton area. We serve the Edmonton area. And we'll basically tackle anything from commercial, residential, plumbing, HVAC, service, you know, and I've been involved for the last 4 years with Weiss-Johnson, specifically in the specialized retrofit department. So kind of right in the emergence of this, the grant programs that have come out, we've had to adapt and sort of shift into a whole new industry and influx of technology and all the different manufacturers out there as far as air source, heat pumps, water-based systems, fully electric hybrid systems. But today we're going to focus mainly on single-family retrofits, which is 98% of what I'm getting into, and I help off, you know, commercial and things like that. But yeah, I've always been I tried to keep my finger on the pulse of the alternative energy department in anything, and I think I see Jim Sandercock in the chat here. So we helped him out on his project on a deep energy retrofit, which would be a whole other webinar. But yeah, so I would be calling myself a self-proclaimed nerd because I do like to keep on with all the different techs out there and explaining it to homeowners day in and day out. I got a passion for it. So so getting into this a little deeper, we have so many options to look at, but like we said, we're going to focus on sort of more of what we've been after, which is the gas hybridized version. So pure electric, it's going to include an fully electric system. The client wants to get off natural gas. So they're going to be looking at really modeling those systems, and you have to really focus on a lot of the homework. Not that you don't on the gas hybrid, but with using a gas furnace as a backup, it's something that everybody knows and we can rely on. We don't have to upgrade panels. You know, it's a lot of the infrastructure is existing. So yeah, like you can see, we've done mostly gas hybrids, which is what we'll be focusing on here. So focusing on gas hybrids now, I apologize. Obviously, I didn't label this fully, but the left-hand unit is your heat pump. You got the furnace, and then to the furthest right is your coil. That coil would be going on your furnace and acting as a primary heat we set it to primary heat. So, you know, shoulder seasons, we're going to be using that coil until it gets a little colder, and we obviously have to use the gas backup. And this is based on economics. I'll get into the deeper details of how we, you know, go about understanding what the client actually wants to do. But to compare these different types of gas hybrid systems is important to note. We have a non-communicating heat pump and a communicating heat pump. With the communicating heat pump, we'll go through sort of the first two would be a thermostat type. Non-communicating, we have a basic North American thermostat. That would be a 24-volt signal. Switching on-off signals is something that we all know very well. All service techs understand them, and it's been in the industry for as long as I can remember. Communicating heat pumps, digital systems, been around forever. Well, not forever, sorry. Long, but more in the air conditioning industry. You know, we've had them. Mitsubishi, Fujitsu, a lot of those use zeros and ones to send data, and not 24-volt signals. And the refrigerant metering would be different. You'd have a thermostatic TXV on the non-communicating heat pump and an electronic EXV on the communicating heat pump. I'm going to keep fairly brief on that. You can go into the weeds with all sorts of things, but just know that the complexity grows considerably when you get into a communicating heat pump. In regards to how it controls its mechanisms and fans and things like that, it's speaking to the outdoor unit and the indoor unit all in tandem with a lot of algorithms built into it. Comparing the installation practices, you know, we've done non-communicating systems all the time. As I mentioned, there's just more complexity to the communicating, so they're a little bit more challenging, and you can run into some issues with, you know, control wiring being, you know, it can have interference. If it's up against a line voltage wire, you'll get some funky readings. We just have to work through it. And then reliability, I would say they're very similar. It's just getting to understand how they actually function and understanding the service. We have a learning curve right now on all sorts of technology. Efficiency, a slight curve ahead on the communicating because everything is working in tandem. The electricity usage is harvested very, very well. And it's always, so the thermostat is always speaking to the outdoor heat pump, and it's always speaking to the indoor furnace. And so everything is monitored, whereas a non-communicating system, it's controlled by temperature. So it's just sending temperature back to the compressor and understanding how that's running. It's very simple. The HSPF factor, which is heating seasonal performance factor, is we can find it slightly better on a communicating heat pump as well. Now, because I'm a contractor, we obviously will be giving you prices. This is widely diverse across Canada, and please take this as a rough idea. This is basically in our area as a general guideline. Typical heat pump that's non-communicating would only be about $2,000 to $3,000 more than an AC, which is why a lot of people go that route. It's not a huge dent in their pocketbook, whereas a communicating system could be quite expensive. So you're looking at $6,000 to $8,000 more than AC. And you know, you're not looking at the cost of a new furnace. If your existing furnace isn't communicating, we have to remove it and get a new one. Same with the new thermostat, which you can see is a little bit more cost difference on the typical 24-volt. So that's that. Now, sitting across from a homeowner, what the heck do we do? Like, where do we go? We always ask with Weiss-Johnson, what are you actually after? First, we're not going to tell them what to do. Heat pumps, there's a lot of misinformation out there. People can start with a goal and end up somewhere else, but I always like to write down what they're after, and you can see the vast majority of people are after comfort. Air conditioning has been super hot lately, so a lot of people are after air conditioning. And it's getting to the point where it's a real safety concern for people. So if they're already considering air conditioning, we always have to mention heat pump in there now in the same breath, because they're not that much more. The cold climate units have come down considerably in price. The technology has gotten better, and so we're kind of meeting in the middle. And there's always the blend to the second largest goal would be the utility savings. Both of those are usually at the top of the list, where most people, there's a handful that would actually want to save carbon. As much as we love to think that people would love to save the planet, most people are really looking for comfort and utility savings. And resiliency, some off-grid people would really love the ability to have a fully electric system, but that's a whole other webinar. Okay, so there's a lot of different ways for a homeowner to access some data on their own. They don't need me to come over. Right now, I think it's CanMet, which is the Canadian Climate Institute, released a really handy heat pump calculator that people can go on from Edmonton, all different regions of the country. If you don't know about it, the link's down at the bottom, and you can plug in where you are, what you're after, and it gives you some background, although they do not have a cold climate heat pump with gas backup on there. So that would be great if they could add that in there too. And there's some caveats in here, obviously, reading through it, that bottom small fine print, these results do not model the future, which is impossible to do. So it's tricky for people to understand that, and me as a contract to model that. I should say that we are installers. We are not modelers. We work with any modeler, which there's a lot of them now, to help us understand what the utility savings could be, what the offset energy is, all those details. And here's another cool, basic slide that would be popped up from the calculator as well. And you'll have this information, although it doesn't show a gas hybrid version. I just thought we'd kind of like to give you a little bit of an idea of what you can get being a homeowner, designer, or just really interested in the subject of heat pumps. So one thing that always comes up, we have to look at the house as a system, and HVAC contractors like myself, we're learning how to do that. We're used to changing furnaces, changing air conditioners, now heat pumps. Now we got to think about a lot more. And so we have solar in the mix. Some people have solar, some people are looking to do solar. So that has to be part of the equation when we're discussing everything. So as an example job, I'm going to scroll through this with a broad stroke here, but we go through a lot of the different things, and this is just the major ones. So here we have a home, 2002. It's a 2-story, 2x6 walls. It says very important, below 9 air changes per hour is very high. And that's based on a blower door that was taken from an energy advisor because they wanted to take advantage of the Canada Greener Homes program. So I also have to do a heat loss calculation as a contractor. We use HOT 2000, and it came out to 92,000. I'd like to cross-reference with the energy guide evaluation. And then we look at source energy. So most people have a 100 amp breaker. I'd say 99% of the population does. They wanted future solar, photovoltaic, they want to keep their natural gas, keep grid tied electric, and he has a wood fireplace that he's more than willing to stock up. So this guy, which is the reason why his air changes is so high, because he has an open hearth fireplace. So it's just something that we have to deal with. And these homes are, they're old. So this is 2 furnaces existing, 80% efficient furnaces. And basically we have a number of directions that we can go from here. I'll go back to this, but going downstairs and talking to the homeowner, and we kind of hover around, hover around the mechanical room. I always say, upgrade your envelope first. No matter how you want to do this, what I'm going to give you, you got to fix that first. And that's one thing that, we should be, as mechanical contractors, giving information to homeowners that, like, our systems can be smaller if you do some of the non-moving part upgrades first with windows, doors, insulation, and whatnot. Makes our jobs a lot easier. It's just very hard to predict, and it's very hard to model. We have to rely on contractors to do this work, and sometimes the numbers don't line up when they're done. So that's a challenge. So yeah, anyway, I highlighted the areas which I find are the most important, and I really stress to homeowners. So going back here, we have lots of different, we can put in 2 different furnaces, 2 different heat pumps, serving different floors. We always option 1 furnace zoned with 1 heat pump if it's possible. So that's actually what we did here. We got through a lot of different iterations, had to do a lot of notes. It's yeah, it's a challenge. And the largest thing, and I'm sure Jordan's going to say the same thing, is that we need to understand the CFM limitations of your current ductwork. Otherwise, the heat pump will not work correctly, no matter which system you put in, fully electric or hybrid. And that's probably one of the biggest hurdles we have today, because ductwork is atrocious in some homes, to put it lightly. And it's the major cause for service-related issues. So you have to use this. If you're an HVAC contractor, you know what that is. Just pull out your duct layer. And then also going on to, I'll go back to this, but using programs, heat pump selection guides that, you know, the Enercan has. We use that as a tool to understand what the heat pump can do within the base infrastructure that we have. So this is ultimately what we chose to do. I had to make a drawing to understand it in my own mind, and the clients, and in the installer's mind. And so a few things you had to take a look at was space. It doesn't take up any more footprint. In fact, it's less footprint than the 2, obviously. We just have to figure out how we tie it all together. So it's a challenge. It's not easy. Ultimately, that's what it came out and looked like. We had to put more airflow at the bottom of the furnace. We just couldn't get enough, so we put it on a stand. It's ran great. Now, looking at the outside, it was another challenge, as the AC was run to the other side of the sidewalk, underground line sets. It's not a good thing to do a heat pump with a long line set outside. You're going to lose all that precious heat from the compressor through losses to the atmosphere. So we had to change up that situation. And so we gave them a pad and stand, moved it around the corner. And this is probably another one of those very important things that you have to make sure that these are secured well. They're very heavy. A lot of ice is going to build up around them, so that's why we have them on a stand. And so we have to make sure that that's allowed for in the insulated line sets. They got to be as insulated as we can, and leave a lot of room for forethought on this part. I just did another one quickly because this is another scenario where it's challenging, because he wanted to put the heat pumps in the backyard, where this is a fully electric system, and actually these are going to produce a lot of ice because they do not shut off. Whereas this system, being gas hybrid, you know, this is going to run till about 10 degree, minus 10, I think in this instance. And then the balance point, you know, kind of lines up around there, and then the gas furnace would kick in. But in this instance, that electric based system is going to run that heat pump all year. So a lot of ice is created. He wanted 2 heat pumps. So we had to make sure that the ice didn't spill onto the sidewalk. So we ended up putting in these ice wells. We developed these a few years ago during the Sundance retrofit project, which I think there was over, I can't remember, there was 24 units or something like that. It was a lot of units. And this was with the Retrofit Canada with Peter Amarongan, who I consider to be a real pioneer in Edmonton. And I have to give kudos, because we developed this together, Sewer Fix with Renew. And they work great. They just store the ice, they hold it, and then release it through rock crush at the bottom. You don't have to contain it, put it anywhere, it just does its thing. So going back to this is the modeling coordination part, which is probably the most challenging thing for us as contractors in HVAC, because we are not modelers, but we have to understand it. And so I use I really like the Enercan. Well, we have to use the Enercan selection heat pump selection guide, which I don't have a slide for here. I just find that the National Resources, or sorry, the Northeast Energy Efficiency Partnerships, the NEEP, has this output, which we can see Now I don't have a pointer, but this will give us predicted balance points, potential low load cycling, where the system can be oversized, which is just as bad, right? This is a whole webinar in itself, but I just thought I'd mention that this is a super important step to understand what we're getting into. And trying to link in solar production into this it's a lot of email chains that go around between solar contractors, homeowners, knowing how much solar we can put on the roof to offset what we're going to need for the heat pump, and if it's going to make sense. Sometimes it's just an abort mission. We can't get enough solar up there to make it worthwhile. So yeah, we need to know that. Yeah, so getting through some key points, I'm going to get to the end here. We need to assess goals. We need to understand what the client wants to do, what everybody wants to do, and then see if they make sense. We have to do the homework. We got to do our modeling. Envelope first. If it's too high, do the envelope. Don't do the heat pump. Don't get into a gas hybrid, fully electric, any of it. If you don't, focus on some of the easier changes. Must confirm duct limitations, CFM sizing, all those important characteristics of the existing home. Like the electrical panel. Most times, if you're going fully electric, you got to upgrade the panel. That's a hidden cost. Sometimes it's very expensive. You have to go through equipment selections. There's a lot of different manufacturers out there, and each one has different HRI ratings, and we have to understand what the limitations of the equipment is. We need to know what backup systems we're going to use, obviously, and how they're going to function. Like currently, right now, one of the challenges we have is the auxiliary runtime on heat pumps, settings on the thermostats, integrating thermostat with the backup heat source as the furnace. Sometimes we'll have to run to basically prevent cold air from coming into the home when we're on defrost mode. I wish I had more time because there's a lot of technical details I'd love to get into, but we have more presenters. Yeah, this is part of the same point here on thermostat control and integration. And then you must commission properly. You got to sit on a bucket and watch these systems work. And if we have to come back in the winter, if we install in the summer, we got to come back in the winter and make sure they're running ideally. And then set your balance points. This is tricky because for us, we have an idea based on the modeling, but if a client has solar, each year they're going to produce more or less. They're going to have a little bit more offset some years, a little bit less. So it's a developing thing that we're learning how to do. And then homeowner instruction. The homeowner needs to know how to turn up the thresholds on the heat pump cutout settings on the thermostat. They need to know all of those things. So these are some of the challenges that we have to face. But it's fun. Yeah, sorry, I skipped ahead here. 4 major challenges that we have, and this is the last slide. Access to training and resources for everybody, including like the contractors that we have, the designers. It would be great if we had a program that could put everything all together. We're just learning on the fly. We're reading manuals. We're doing test case scenarios. We have almost 1,500 systems out there right now. So there's our classroom to date. And yeah, we really need to hammer home a lot of the challenges because we need to know what the deficiencies are of these, and knowing the ratings from different manufacturers and understand how to read them. That's a challenge. There's a lot of different information out there, and we can get lost in it. And predicting these utility and carbon savings is very hard for us to do too. And as I mentioned before, we try to rely on the upgrades to the envelope first so that we can model a smaller heating load, so that we can give you a smaller heat pump. But if we're relying on contractors that don't exist or don't really care about envelope, it makes this that much harder. There's a few, but there's not many. And then verifying and testing field data. As I mentioned, we have a lot of systems out there. Hey, Jim, let's start monitoring some of these, getting some capstone projects going so we can see what's going on and we can correct things as we go. That's big. That's actually 5 major challenges. I changed that. So yeah, anyway, thanks for letting me kind of spill what we've been doing the last little while.
Awesome, Don.
Yeah.
Really appreciate that.
Yeah.
We're going to save questions to the end. So, as I said, please, if you have questions, please type them into the chat. But we're going to hand it over to Jordan here so that he can start. Tell us about his experiences with the installations.
Okay.
All right. Well, thanks.
Sure.
Yes. So my name is Jordan Hilton. I work for AirTech Services. I'll do a quick correction. I'm not the owner, just their senior residential, kind of everything residential in terms of technician, sales, tech support, service, you name it. I've been doing this kind of work for just over 20 years. Started in 2001 as a building operator at the airport in Calgary, looking after the heating, air conditioning there. Moved when I got married a few years later to Medicine Hat, got my refrigeration ticket, worked for a couple companies there before moving back home to Strathmore, and been the last 2.5 years with AirTech and changing my whole way of thinking, getting into this cold climate and high-end systems. There's a lot of things that Don said that I completely agree with. We are a Daikin dealer, so Daikin is our main brand that we supply. Daikin offers an incredible range of products that can do all kinds of things. So we do both fully electric systems, which is known as their Sky Air, cold climate heat pumps, as well as hybrid systems where we pair what's known as their heat pump compare with the gas furnace. I'm more and more of a fan of matched systems as opposed to third party, especially the communicating side of things. It's given us a lot of tools, and myself in particular. We have a Daikin cloud service. So when they're hooked up to their Wi-Fi, we can monitor a lot of settings and change things remotely. I will also get any alarms. As currently, I'm the only guy on call for our residential side for the last 2 years. And on our own systems, I've been out 2 or 3 times over the last 2 years for breakdown stuff. It's kind of, I can see problems before my customers know them. I had one this morning for a customer out in Weiss, and they had a power bump. So that logged that there was a power issue. I was able to see that. I reached out to him. He said, "Yep, thank you. We've got the power reset. Everything's back up and running." We have a couple builders that we work for that we do all electric homes. The biggest thing is they know what they're doing and we know what we're doing. So they have a proper heat loss modeling before it's built. We order the equipment and the backup heat, electric heat to go with it. That's extremely important. As Don had mentioned, airflow is really important. So a centrally ducted all electric, your airflow requirements for electric or heat pumps is far more than your 30-year-old gas furnace. You'll need a lot more volume of air. And if you want a good volume of air, you need properly sized ductworks. Otherwise, your velocity goes up, which means they're noisier. And then you run into blower issues and you have breakdowns. Things don't work. You get high pressure situations inside and it's shut down. And then you get this really negative narrative around heat pumps and that they don't work, which is it's false. They work. They can work very well, but it is critical that you size them properly and that you commission them properly. We've also inherited a few other competition systems that just don't take the time to take the proper training. And they've installed things that generally are too big because they do their own heat loss, try and put in a heat pump that they think will be the right for the house. But as Don again had said, if the ductwork doesn't support it, it's not going to work well. And there are very little things you can do after the fact to make something that's not the right product work reliably. We also do zone systems. So 2 furnaces into one. We've done quite a few of those. I've got that in my own house. I love how it works. I prefer proprietary stuff. So if you're getting a zone system, having a third-party zone setup, I find does not generally work as well as a proprietary where it's all the same brand. With ours, it's all communicating. So instead of having something that's known as a bypass damper, as you're trying to move all the airflow through half of the ductwork, instead of bypassing that air and just cycling it within the furnace room, we tell the system to slow the airflow down. You can only have this much capacity for this zone. They work far better, far reliable in that situation. It can work with a third party, but you do have to set it up properly and size your equipment properly. Where are we now on the rest of my list here? So the biggest, I get a lot of customers that want to go all electric, and that can be done, but building envelope is kind of the first thing you have to do. If you want to go all electric, you have to bring your heat loss on your house down pretty considerably. Just for an example, 10 kilowatt electric backup heat, the backup heat alone requires 60 amps worth of service. So if 90% of your houses have 100 amp service to the house, your 60% of that will be taken up with just the backup electric heat at 10 kilowatts, which is about 35,000 BTUs. Your typical 1,000 square foot bungalow house, what has in it existing is anywhere from 60 to, you can have people that put 120,000 BTU furnace in. It's a lot less heat available with airflow with an electric system. So you definitely need to size properly. And like Don does, before I even give them solutions, when they're wanting to go all electric or anything like that, I ask them what their goals are. Why do you think you want to go that way? And if they want to go that way because they think they're going to save money, usually I stop them right away. Going all electric on your utility bill will generally cost you more money in just about every scenario. When you pair with solar, it's a great setup, a great option. But knowing your heat loss is very critical. So, and that goes as well when you're going hybrid. Knowing how big of a heat pump you can put on there is all depends on ductwork. So, the Daikin Cloud, one of the other things I've used it for as a great tool is I can see the usage from any point in time at any day. So I can compare graphs of outdoor temperature and what percentage either the gas heat is operating or the heat pump. And I've used that as a great tool to size systems. So I'll compare houses that we have. I will use that to determine what size of equipment to put into a new home based on actual data. Some of the cons, yeah, again, airflow. It's really, really critical with these systems. I can't stress it enough. It's the number one problem that we have dealing with problems with the heat pumps. Most of the failures that I see in not only heat pumps, but just in our industry in general are poor sizing and poor installation and commissioning. If you have a contractor working for you that says a furnace is going to last 10 years, you don't want to hire that furnace. You don't want to hire that person. I give everybody a 20-year life expectancy for most equipment, but that's just a number. If things are installed and commissioned properly, regardless of brand name, your equipment should last a long time. I'm going to keep mine fairly short. The all-electric stuff. One of the things we do there, our Sky Air equipment, it's got 100% of its heating capacity down to minus 20 degrees Celsius. We try and size things so that we can utilize the heat pump down to our coldest changeover temperature, which is minus 27. That way, utilizing that COP, even if it's in the 1.7, 1.6, it's still a lot better than 1 and more efficient than your all electric. We don't set up to use electric and the heat pump, as I find from an efficiency standpoint, that's just not very efficient to use that much energy. You should size it to use the heat pump as much as you possibly can to reduce as much energy usage as you can. That's about all I've got for that. And then the changeover temperatures, when we do the hybrid systems, there is no right answer for that. Every single house is different. We might have the same house next door that have different ductwork, one that allows for a slightly larger heat pump, so you can put a slightly colder changeover temperature than the house next door. Cost wise, yes, there's a cost to putting in higher end equipment, but make sure you're doing your homework, not just on the brand, but on the company that's installing it. Not all of us are created equal. Just make sure you know your company that you're using knows their stuff. We have a very good relationship both with our distributor and with our brand. I have the direct numbers of the Daikin Tech trainers for Western Canada, but I've worked with them pretty exclusively on some certain challenges that we have, and they will answer my calls when I need them. So that's all I've got for today. Thank you for the time.
Awesome, Jordan, that was great. I think you probably did a really good job of setting up Darrell here, because both Dawn and yourself have touched on the importance of airflow, and I think Darrell's going to give us a little bit more insight into that. So we'll hand it over to Darrell here.
Again, thank you. Energy saving products. We're a manufacturer. And I got to thank Jordan and Dawn. Yes, you led me into a great subject and allows me to talk about our product. We are a manufacturer. We're located in Edmonton, Alberta. We've been in business for 40 years. We make an air handler. Again, we're noted for high velocity systems. It's a smaller duct. An introduction to high velocity, well, you can notice on the screen that typically our ductwork is smaller when we talk about high velocity. So very, very unique that way. How the system works, well, I'm going to talk about low velocity, I'm going to talk about high velocity, and I'm also going to fill in the gaps that both Jordan and Dawn talked about. So conventional, let's talk about that. Pressure is converted to velocity at the fan cabinet. It requires squeezing of the air. The throw and the diffusion method is very common. And what we're getting out of conventional forced air is the warm air will rise, the cold air will drop, lazy airflow, not enough velocity to create any stirring of the room, and stratification of hot and cold spots are very common. Well, high velocity, definitely different. We're maintaining the static pressure in the ductwork. That means that every joint's sealed. We're maintaining the static pressure in the ductwork, and it's bouncing off the end cap to back to the fan coil, maintaining that equal airflow to all the outlets. Now, the pressure that normally on a conventional system is created at the fan cabinet, well, now we're letting that velocity out of the outlet. And when that velocity comes out of the outlet, it's simple principle of Venturi action happens. So in a Venturi action, it's taking the rest of the air in that room and stirring up the room side to side, top to bottom. It's like a sprinkler hose or a soaking hose. You connect that hose to the tap, and it doesn't matter if it's the first outlet or the last outlet, it's the same amount of volume coming out of it. Well, that's high velocity. Now, the Venturi principle draws air into a low pressure zone and creating gentle stirring of the room air, and the entire room gets mixed and eliminating that dead air spots and air stratification. Again, what does this mean for system design? Flexibility and air handler and duct placement? Well, again, we're using small ductwork. We can fit one plenum in the joist space and now take off a flex and go to each individual room to dissipate that air instead of running, 5-inch or 6-inch pipes, and we're looking for a lot of wall space to bring them up. Again, smaller ductwork. Another application of flexible ductwork, we can go in the ceiling, the joist space underneath. We're very, very adaptable to all situations, whether it's retrofit or new construction. Now I'm going to show you a picture of a house, and we're going to talk about return air, and I'm going to talk about my outlets. My outlets can come up through the floor, the ceiling, or through the wall. And return air, it's same as a conventional. I need a return air at each level. If you can get a return air at each major room, that's a better system. But code reads one at each level. It doesn't matter to us. But the uniqueness is the smaller ductwork and where we can put outlets. So again, what does this mean for system design, flexibility, and vent placement? Well, we've got two sizes of outlets. We've got a 2-inch and a HE. Well, what's an HE? Well, HE is 2 7/8. It's double the volume of a 2-inch outlet. Usually a 2-inch outlet will go in a bathroom. The HE goes into the bigger rooms. Floor applications. Again, we're going 6 inches off the wall, whether it's the floor or the ceiling, never in the middle of the room. And we don't have to be in front of the heat loss or heat gain locations, typically windows. I need to just get in that room, and that's how well I move the air. Wall applications, also beautiful. High wall applications, I can move that air. It's not disturbing anybody. So all kind of applications like that. Ceiling, another one. It looks like a pot light. There's no need for the grill in it. I can take the grill out and it looks exactly like a pot light. Well, heat pumps. I want to talk about that because we do offer a heat pump. And the heat pumps and the information I'm going to fill in here is since an air source heat pump has a minimum outdoor operating temperature between minus 15 and 25, and reducing the heating capacity very cold temperatures, it's important to consider supplementary heat source. Okay, for a air source heat pump operation, supplementary. So something extra that you might need because it doesn't become efficient for the heat pump to run. So we can do that with our air handlers. We've got different options. We've got all electric, or we talked about hybrid systems, both Jordan and Don, whether it's gas or electric. We can do that with our air handlers. Our air handlers do not accept gas. We need either a hot water, we need electrical. That's what we need to operate or give a heat source. Now, an air source heat pump has 3 cycles. It has a heating cycle, providing thermal energy to the building, a cooling cycle, removing that thermal energy out of the building, and a defrost cycle. What do you mean by defrost cycle? Well, on a cold day, that unit will defrost. It'll drop moisture out of it. And you've heard both Jordan and Don talk about it. That's important to understand what happens on a defrost cycle. If it goes on a defrost cycle, that means you're not getting heat out of the heat pump. So again, heat pumps work on cooling coils. You must need a cooling coil. Our cooling coils go on the return air side of our air handlers, and the refrigerant gets forced backwards into, if it's in a heating cycle, or the proper way if it's in a cooling cycle. So you must have an air conditioning coil. Now, our air conditioning coil, it's heat pump ready. It's got adjustable TXV ready to go, accepting a heat pump application. And it's the same footprint as a fan coil. So again, compact. Our fan coil's compact. That's what you're seeing right there is our fan coil with a cooling coil underneath and ductwork on it. We have electric strips. We have 2 different kind of electric strips, and these electric strips don't go in your ductwork. They actually fit in our cabinet. This one electric strip is capable of a 2-stage capabilities. The next one is a variable speed. Now, the variable speed is very unique, or variable electric modulation, I should say. It's giving you what you need at that time. It's not overheating. So being efficient is really critical. So this is how it fits in our cabinet. It fits right into our cabinet of our air handler. You don't have to build anything special. Now, the other thing that we offer is a hot water coil. Our hot water coil is very unique. It's good for domestic water, good for boiler water, field installation, easy. Again, low pressure drop. Again, this hot water coil is like a hybrid system. You can use your heat pump and then still run hot water through it to give you the secondary heating. So this is a picture that's really typical nowadays. You're seeing a lot of contractors or homeowners use this. They're using a demand hot water tank. They're using that domestic water, using a mixing valve, giving you hot water, but yet there's the domestic water going through my water coil. I'm distributing it through my Flexus, and you see the heat pump on the back end there going through my refrigerant coil that's on my air handler, and then HRV or ERV connected to the return air ductwork. That's very common. So high velocity, low velocity air handlers, we have smart motors, VFD drive, multi-configurations. I can go upflow, downflow, or horizontal. Zoning capabilities. Our high velocity is able to do zoning, no bypass, amount of 4 hoods on it. You could have 4 different thermostats connected to it. Powder coated cabinets, 110, 220, acoustic insulation on the inside. And again, we have the option of a water coil, that 6-row coil, which is very unique, takes low water temperature and gives you the best BTUs. Our HVS heat pumps, we have 2-ton, 3-ton, 5-ton capabilities. Easy installation, operating temperatures as low as minus 30 for net zero projects. quiet operations, 57 decibels, and energy efficient zoning. So it ramps down. These are variable speed condensers. They ramp down to 20% of its capabilities. I want to talk about heat distribution because that was one of the things I wanted to clear up here. I'm sorry, I don't know what happened there. Heat pump systems generally supply a greater volume of airflow or lower temperature. So a heat pump's going to give you lower temperature than a furnace. A furnace, that hot air is definitely warmer compared to the furnace. So as such, it is very important to examine the supply airflow of your system, how it may compare to the airflow capacity of the existing ducts. If the heat pump airflow exceeds the capacity of the existing ducting, you may have noise or issues increasing the fan energy. Well, then your fan has to work harder. That's more energy that you're using. New heat pump systems should be designed accordingly to an established practices. Apologize for that, no idea why. Installation is refitted, and the existing ductwork should be carefully examined to ensure that it's adequate. So really important to understand that. Here's our heat pumps outside. We abuse our heat pump. We want to make sure that it lasts longer in all kind of conditions. And you notice that the one in the middle is off the ground. And again, Don talked about that and Jordan talked about that. Heat pumps, cooling season performance, SEER rating should be at 14 SEER. That's a rating that the Canada government rates these. That's the minimum SEER on a cooling. And you can get them from 14 to 42 SEER rating. Heating season performance, that is HSPF. The minimum in the Canada government is 7.1. So, and again, that's up to 7 to 13 rating on the heating side of a heat pump. So other criteria that's really important is sizing. Okay? Again, I don't think you can hear that enough about sizing. Select the unit with the high HSPF as practical. Practical, that's a key word here. For units with comparable HSPF ratings, check their steady rate ratings at -8, the lower temperature rating. The unit with the higher value will be the most efficient one in your region. Defrost. Select a unit with demand defrost control. This minimizes defrost cycles, which reduces the supplementary and heat pump energy use. Sound rating. Sound is measured in units called decibels. The lower the value, the lower the sound power emitted by the outdoor unit. Higher decibel level, the louder the noise. Most heat pumps have a sound rating of 76 decibels or lower. Here's 29 tons of cooling heat pumps on a side of a building working a commercial project. These are heat pumps of ours that do both heating and cooling. Here's another picture of a heat pump. You see how it's raised off the ground? That is so important with a heat pump because it needs to go on defrost cycle and it will defrost and the water will drip. And if you didn't have it off the ground, it could freeze and build up ice and damage your unit.
Darrell, I'm just a little cognizant of time.
Okay, I'm done.
Leave a minute.
Good timing. Energy saving products. Here's our products, all our products in here. Thank you very kindly for the opportunity to speak.
Oh, Darrell, appreciate it. And real thanks to all our speakers. I think you guys have really highlighted just how complicated this whole issue can be and all the different factors and the learning curve that I think the whole industry is going through in order to understand the different aspects of heat pumps. I know we do have a couple of questions in the chat, so I'm going to just throw it back out to Pam really quick to see if we have a couple questions we want to highlight.
Yeah. So the first one we can start with is a question for Dawn. And it was Jim asking, how often are electricians installing load sharing breakers to deal with higher electricity loads? Or are you typically seeing that you're just upgrading the panel from 100 to 200 amp?
That's a good question. You can hear me, right? You hear me okay? Yeah. Hey, Jim. Yeah. So I would say upgrading the panel is very rare. It's a lot of times it's underground power, so that can be upwards of $20,000 to $30,000 to trench. So I'd say 90% of the time we're putting in one or more load shed devices, depending if they want an electric car and whatnot.
And I'm just going to plug that we're looking to have some additional training in the new year that looks at electricity upgrades relative to heat pump upgrades. NRCan through the LEAP program has some excellent modules available for looking at novel ways to handle sizing of the panels and getting away with heat pump upgrades without having to add panel upgrades. So we're hoping to see that more in the new year here.
Good.
And then we had a question from Lisa asking if a NEEP, so it's NEEP heat pump database for Canada would be a valuable resource if any.
That's another good question. And so basically what you can do is you can go in there and you can set the design outdoor temperature. So essentially we can mimic Edmonton based on that software. But that's a good question. That's kind of the one I had too. Both of them are good. NRCan's heat pump selection guide and NEEP are good. I try to cross-reference both.
And then there was a follow-up here on the load share device comment, just asking if electrical inspectors in Edmonton are familiar with load share devices and if there's any issues that are coming up because of unfamiliarity from the electrical inspectors.
Yeah, I haven't experienced it. It's something that we've had to do with basement suites already, where they want 2 stoves, 2 dryers, right? So they've been looking at this in the past. The major challenge comes with Epcor, with the solar. We are limited. Sorry, I'm breaking apart from the question, but when it comes to inspections on the municipal side, we really have a challenge when it comes to the production, more so than anything, and knowing that we're not going to overproduce on the solar. That's the recent challenge.
And there was a question here from Arnold asking who to contact for correct HVAC engineering. And Arnold, you might have to specify if you're looking at residential or commercial, as I would imagine that would make a difference. But I don't know if Darrell, Dawn, or Jordan has, he did confirm residential.
Yeah, so there's a few with residential engineering. It's not common unless you're doing new construction. So in that case, Renew has always been a good resource. RENU. Yeah, it's one offering. There's a few of them up there.
I'd like to jump in also. We offer a free service at Energy Saving Products of a heat loss, heat gain calculation, which involves our equipment. And we do it again with residential and the market and retrofits and new construction, where our program tells them how many vents they need to have in each room. So we do a room-to-room heat loss that indicates that. So absolutely, that's a free service that we offer. The other thing I just wanted to mention, we talked about electrical with 2 stoves in a basement suite and whatnot. There's an Alberta code that if it's a legal suite, you've got to have 2 separate appliances. You can't use the same heat source for a legal suite anymore. It has to be a separate appliance or a separate air handler, separate furnace. That's what I'm getting at.
Excellent.
Awesome.
Great.
Well, just cognizant of time here, so I'm just going to take a second here. I just want to thank everybody for attending today. Please do check out all of our events from our event calendar page. All of these are posted there with links for registration and details. And again, thanks again to our speakers for providing all the insight they can.